Howdy. Second try I tried to make this video, which is the part 3 of these two. Or maybe part 4 already. Since I made this one quick here, it's getting amazing. Yeah, and because it got so amazing, it was so difficult to get some video together. Now probably I manage. Because also this video here, newly discovered mud volcano, Borealis volcano, in Norway, is something which could probably relate to the copper in Outokumpu. And let's start off with this picture. On the left we have the coat of arms. And as I showed in the previous video, here we have the sign of Venus, which is also very visible in the city itself. And I was wondering about this coat of arms. Could the yellow be for sulfur and the red for burned sulfur? We have tridents, thunderbolts, in other words, electric discharge, signs. The trident. I also have been talking about these already, like this surface conductivity anomaly map and the surprising similarities with the polar cusp reconnection of Earth's magnetosphere. We also could take a look at this picture, which is from Fuego. Here we have some volcanic plasma. It's not good quality, but I have a picture. And that's the eruption plume from the actual volcano. And we have Venus in the background and also Jupiter. Yeah, I think that's a pretty nice picture to have all these things in one picture. And yet once again the surface conductivity anomaly with some other similarities. This is Florida here. Maybe this could be Florida as well here. You know? And this region would be this region. There is also Mars on the left. And the crooked smile from Andrew Hall. It could resemble these kind of things, like it could be somewhat similar. But I leave it up to you if you find similarities or if you disagree. I just want to bring them forth, that there could be also a possibility that this surface conductivity anomaly has similarities with these other things. I think it has. There is yet another plasma phenomena at this Fuego volcano. And the thing is, if we are talking about plasma, or Earth in general, we have to understand that Earth is an electrical body. It's a leaky capacitor in space. So there is energy flowing through it. And this kind of plasma phenomena beside volcanic plumes, they could be a very good indicator of the nature or the electrical nature of Earth. And since I try to still talk about the copper here in Outokumpu, you have to know that, I assume that you know, we have to remember that we have the telluric currents, which are in the ground. There are electrical currents which go in the ground, and we have the electrical currents which are in the atmosphere. Usually they get best visible when we have a lightning strike. And there is like negative and positive lightning strikes. Positive, they are reaching from the ground up. And they are related, I think, to some kind of the telluric currents combined with the geometry of the landscape and also the energy flows from Earth's interior to the outer side. And energy goes both ways. So obviously, if we have a volcanic eruption, the energy comes more or less from beneath, it goes up and it erupts. But does it go any further than that? Does it do any more than just spewing lava and gases and ash and these kind of things? Could there be any proof that there is a real electrical thing going on at some volcanic eruptions? Fuego. Lightning interacts with fuego plume. And if you watch at this picture, it's really obvious, in my opinion, that this lightning strike goes away from the plume, it goes upwards. Positive lightning. From a volcanic plume. And it has also a connection to solar activity. So it's all electrical in nature. And partially I have been talking about this also in my mountain water paper, which is basically talking about mountains. And I took the Alps as the main theme in this paper, because once I stumbled across this article, textbooks and geoscientists may be wrong about how the Alps were formed. The thought-provoking article that led to question of how many other accepted theories might be wrong too. Yeah, we have cycles, we have dragon castles, and if you scroll down still a little bit, we have this geothermal activity map, which I will show you later once again. But we have these sea urchin spines, jewel antennas, an illustration of energy exchange between ground and sky by Giovanni Gregori. The following picture, figure 10, illustrates the continuous connection between ground and sky, which is therefore a circuit and will react immediately according to the environmental electromagnetic changes. The environmental changes Earth experiences are mainly driven by the Sun, and the Sun's environment changes accordingly to the changes in the connection to the center of our galaxy. These are the sea urchin spines. Still going down a little bit. We have this picture here. Comparison of an arc discharge event on the Sun and a theoretical counterpart on Earth. The form and shape of the discharge would match the scars on the surface of Earth's crust. Like I said, this is mainly about the Alps. Here we have a solar flare, and where these magnetic field lines are rising up, it would be here. And the places where this goes through that, it would go like this. And in the middle we get the Alps. Here we have the Ivo volcano in the north and maybe Campifli in the south. And this is just an example, but it would match what we have here to see. The Alps, they're rather big. You will notice them if you go close. We have these kind of electrical or of energy exchange between ground and sky, which is also associated with geothermal activity. And I think geothermal activity is volcanic in nature. Still, we have to go down a little bit, I think, to this picture. There might be a plasmoid at Earth's center, which provides the heat, which keeps Earth alive. And I've been talking about why I think it could be that Earth is a blue planet because of the layering of the elements in the Birkeland current, which I tried to illustrate here. You just have to imagine that this Birkeland current diagram here in the middle would be bigger and it would fit the actual size of Earth, but since I cannot do any overlays, you wouldn't see the Earth or you wouldn't see anything of that. So I had to make it like that. On the other side of a Birkeland current, and I turned it 90 degrees in order to make it look like a sphere. Here would be the plasmoid. Or maybe here. I don't know if the plasmoid has a center. It has to have a center. But what's at the center of the plasmoid? I don't know. So here on the other side we have hydrogen and oxygen, as we do on Earth. Maybe that's the reason why we have a blue planet. And if you go a little bit more down, here we have the MOHO probably, because it's a double layer of the Birkeland current or the Birkeland currentish plasmoid. Maybe it could be the MOHO. Why is this important? Because, as I stated in this paper, plate tectonic issues the influence of electricity in rock-forming processes and the coherent connection between science, mythology, and history of Finland, the sea pinch stone and the dragon. We have to go down a little bit to the... here we don't have any plate boundaries here in Finland, not anywhere close. You have to go to Iceland to find one. Nonetheless, the geology is very complicated here in Finland, as is visible on these maps. Interesting rock formations in the middle of the city. No one really cares about or knows about. But volcanic activity in Finland. There is no volcanic activity in Finland. Since I wrote this paper, I might have come to a different kind of conclusion since I learned about the volcanism much more. But there is no volcano here which would erupt with lava or stuff, or hasn't erupted for many, 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 many years. So, the MOHO, volcanic activity, Finland. Geothermal activity in Finland. The geothermal potential of Finland is very low, even at its most active points, which are the southern tip of the country. When you go north, it gets less and less. The region of Helsinki and Turku are basically the only ones with some potential. In Helsinki is a geothermal project going where they are drilling the deepest hole in the world to get geothermal energy. The deepest hole in the world. So there is not really geothermal activity. Nonetheless, we have a map of geothermal activity in Finland, and how funny. The Koli area. I have to dive into that if you are interested. You read the paper. In the Koli area, there's a cave, the Devil's Cave, I think, where has been once a mighty witch, and witches are usually male here in Finland, contrary to Central Europe where they're usually women. But anyway, there was a mighty witch living in this cave, and the witch was so mighty it could make the water boil which was coming from the ground. Koli area. Number 1. And there is slightly elevated geothermal potential in that region. So the story from this old witch, there might be something true to that. The plasma rocks number 2, there's also somewhat very slightly enhanced geothermal activity. But in general, there isn't much geothermal activity in Finland. So how does this relate to the MOHO? Let's have a look at the MOHO depth of the European plate. seismohelsinki.fi. The Institute of Geophysics, University of Warsaw, Basteiro, Poland. Institute of Seismology, University of Helsinki, Helsinki, Finland. Here, the MOHO is very deep, somewhat even 60 kilometers, whilst it is rather shallow in Central Europe, where we have the volcanoes, southern Italy, very shallow. If it's shallow, there is much more geothermal activity and, in general, more volcanic activity, which makes this region very interesting. But we won't dive into that now. But we have to touch once again the topic of sulfur. Like I said in my earlier videos, the atmosphere of Venus contains sulfur. So the origin of the sulfur here in Finland, after now I showed you that there isn't really any volcanic activity. Usually sulfur is related to volcanic activity, like Sulphurata. In Campifili Grade is one crater which is totally white, and there are like the Romans already dug the sulfur out of there. That's one source of the sulfur, it comes from volcanoes. And the other one is probably Venus. There might be others, like who knows how many cosmological encounters Earth already experienced before the ones which got recorded in ancient times. So, like dinosaurs didn't write the diary that, yeah, today we had this conjunction of the planets and we had, no idea. But the sulfur, there is sulfur in the copper rock, as I have showed in this picture. That's copper ore from Outokumpu, Finland, which isn't too far away from here, 15 kilometers or something. And before I microwaved it, it had this kind of color. Maybe I have to turn around this stone once because it is really yellow on the side, much yellower than here. But this is how it looked before microwaving it, and after microwaving it was totally red. And as I have showed you in the other videos, you can see at the really bottom of the mine area where the copper ore is in Outokumpu at the old mine, it's really, really red. The stone which was in the microwave sparked and glowed a bit, and afterwards it was red. In other words, I assume or I conclude that the rocks, the bedrocks of Outokumpu must have been once hot in order for them to turn red. Because if you watch here on Wikipedia, sulfur is obviously yellow. And there is also a picture here. Yeah, I show it again. As a solid, sulfur is a characteristic lemon yellow. When burned, sulfur melts into a blood red liquid. Yes. And emits a blue flame. I've proved both of them, since I had blue flames, there was liquid, and the stone turned red. So we might really have to talk about sulfur. Historically and in literature, sulfur is also called brimstone. I have been talking about these also, which means burning stone. Today, almost all elemental sulfur is produced as a byproduct of removing sulfur-containing contaminants from natural gas and petroleum. The greatest commercial use of the element is the production of sulfuric acid for sulfate and phosphate fertilizers and other chemical processes. Sulfur is used in matches, insecticides, and fungicides. Many sulfur compounds are odoriferous, and the smells of odorized natural gas, skunk scent, grapefruit, and garlic are due to organosulfur compounds. Hydrogen sulfide gives the characteristic odor to rotting eggs and other biological processes. Sulfur is an essential element for all life, but almost always in the form of organosulfur compounds or metal sulfates. Sulfur is the 10th most abundant element by mass in the universe and the 5th most on Earth. Though sometimes found in pure native form, sulfur on Earth usually occurs as sulfide and sulfide minerals. And I already noticed just that that's again 20 minutes. Oh man. Well, anyway, they might be still following many videos about this until you get somehow a picture of what I'm talking about. Geoscience World Economic Geology. Origin of the Precambrian copper sulfides of the Outokumpu district, Finland. July 1st, 1978. E. Peltola. Abstract. The Outokumpu region is an integral part of the Precambrian formations of the Kareli-Delic orogeny. The copper deposits discovered in the western part of Karelia mica schist area are associated with a lithologic complex that regularly consists of black schists, serpentinites, and silicous quartz-rich rocks. So if you think in terms of electric geology, if you hear something black, you probably have to assume that it got burned very badly by electrical discharge events. Might the origin be then Venus, some solar activity, some magnetic pole shift things, cracks in Earth's magnetosphere, or whatsoever? Ground touching aurora? You know. Or just really strong thunderstorms, which are back related to the sun again. Black schists, serpentinites. At the plasma rock site, on the right side here, there is this stone carving, which has this interesting part here. Hopefully you can see it. There's one circle, there's this figure, there's another circle, and maybe a cross, and maybe there has been something here too, once. We don't know. But I think this could in a way represent the archetype of Venus, the serpent of creation. And once again, at the plasma rock site, there is also an old copper mine. So this is what I think about serpentinites, these kind of rocks. They are probably made by a dragon, in other words, electrical discharge events, which include very high voltages, temperatures, pressures, and all kinds of other things you can imagine. So whatever's, let's say, material got this treatment, it will form different kinds of things. It depends on the intensity, on the length, and many other things, what it will create at the end. So serpentinites, there are many, many different kinds of serpentinites. But just the name of them, serpent, I cannot make this up. I didn't figure out to give some stone a name, serpentinites, and this was made in 78. And silicous quartz rocks. Silica and quartz is the same thing. But silica can be in a amorphous state or a crystalline state. Your windows at home is quartz, but it got heated, so the crystalline structure of the quartz dissipates. Otherwise, you couldn't see outside. In other words, if there is quartz, which has been partially melted, it needed at least a temperature of somewhat 700 degrees Celsius. And there is no volcanoes really here, so somewhere the heat must have come from. And I think it came from above and not from below. The rock association makes up the coherent stratigraphic sequence known as the Outokumpu zone, a prerequisite for the occurrence of Outokumpu-type ores. In other words, there is a whole copper ore type which carries the name Outokumpu, which is very interesting. The lithological and structural setting, together with the high nickel content of the serpentinite silicous rock association, indicates a genetic relation between its components. Yeah, this is what I try to figure out, how sulfur and copper belong together. And why? What's the thing? The location of this rock association in a specific stratigraphic position corroborates the concept that they were emplaced concurrently with sedimentation. The copper deposits show clear stratigraphic affiliation with the enclosing metasedimentary rocks of the Outokumpu sequence. The stratified structure and systematic relationship between sulfur isotope ratios and stratigraphy in the Outokumpu ore suggests that the sulfides were deposited during sedimentation of the silicous host rock. So they belong together, they were created simultaneously. Yeah, there's sulfur in Venus's atmosphere. The conformable alteration of Carboniferous intercalations with the silicous host and country rock of the Outokumpu ores indicates a common depositional environment. Several lithological and geochemical features of the Carbonaceous schists in the Outokumpu district indicate that they were deposited under stagnant marine conditions. So they assume that it formed under the sea. And I think maybe there could have been water, but I don't think there was, But anyway, the simple mineralogy and high cobalt content of the ore suggests volcanic origin, which might be partially true, since many volcanoes were created by electrical discharge events. Sulfuric isotopic evidence and the compatibility between the radiometric ages of the Outokumpu galenas metavolcanics resulting from Precambrian volcanic activity and black schists support the notion that the Outokumpu stratiform copper ores were formed under conditions characterized by submarine volcanism and a restricted environment of sedimentation. Like I said, I have to read this to you because then you know that I know about this. Also, you know about this then. Because I just try to provide information for you to make up your own mind. The Outokumpu type sulfide deposits seem to be the Precambrian equivalent of more recent massive pyrite deposits of sedimentary volcanogenic origin. We have these signs. I don't know what they're called in English, but I think they're very important. Because first, some days ago, I figured out to read about volcanogenic stones, because I have of these. And then I was thinking there's no volcanoes in Finland. Yeah, I wrote a paper about it, saying that there's no volcanoes. So still, I have volcanogenic stones, and I came to the conclusion that what they think is volcanogenic stone, or most of them, they are not made by volcanoes. They are made by electrical discharge events. Might it be from heaven to ground or in the ground telluric currents, GICs, geomagnetically induced electric currents, and stuff like that. Ground touching auroras. They can be many thousands of degrees hot. The Outokumpu, let's read this again. The Outokumpu type sulfate deposits seem to be the Precambrian equivalent of more recent massive pyrite deposits of sedimentary volcanic origin that differ in location and geologic ages. Pyrite, which needs very much heat and stuff to form. Recent. And I think about it, if this surface conductivity anomaly map I showed you, and I explained earlier that it might be that the magnetosphere got so small that the auroras actually touched the ground, or the polar cusp touched Earth. So the event was probably very quick and very violent. And you get so many things created at once. And if they are dating stuff, they look at some isotopes or whatever carbon dating they are doing, but they don't understand that just a lightning strike can do things what they think take millions of years in a blink of an eye. The ores underwent a regional metamorphism, which they don't tell about what the metamorphism is. Electrical transmutation of the elements, the structured atom model, Edocal, and stuff like this. The ores underwent regional metamorphism. So just in some places, an electrical discharge here, 15 kilometers away from there, nothing happened. So it's regional, just an example. Which modified the structure and composition of the ores in their surroundings. This content is PDF only. Please click on the PDF icon to access. You do not have access to this content. Please speak to your institutional administrator if you feel you should have access. Yeah, if I would ask them, they probably, I don't know, probably wouldn't give me that. But obviously I have to make many more videos to get to the end of that, because I really have a point about positive lightning and electrical discharge events and stuff like this. This is continuing, so maybe one day I can make a short video which contains all the things. Probably not, but let's see. I have to do some garden work now. Thank you. Bye.